Hello everyone. This is the problem of the day. Problem number is 3635, and the problem title is earliest finish time for land and water rights. Yesterday we had the same problem, but it was the rights one, but today it's right two. Okay, it's that previous yesterday it was easy problem. Today we have medium level. I think problem statement goes the same way, but the only change is in constraint. Okay, and let's see how we actually did solve the last problem. Okay, what we were doing. Um okay, so since the time constraint, like the length of the n and m is very low. So what was n and m? N and m was the length of like options to pick land rights. So there are n numbers of land rights and there are m numbers of land rights. Okay, and so at first what we did, we iterate over the first array, that is the land rights, and what we did, we found min L. So it was just start L plus duration L, so it was like that. And after that we iterated over the water rights, and what we did, we found out the min W, minimum for the length and minimum for the water rights, land and water. Okay, start time plus the duration, and result is nothing but minimum of result plus minimum of this minimum land, comma, and start water. Okay, okay, plus water duration. So we found out the most like minimum time for the land rights. What time means the starting time plus the duration, and for water right, what we are checking what is the most minimum time will be for the water rights, that is for the land rights, that is this one, plus this one, or it may be the water rights for the water and then the duration. And yeah, we will need to find the any of them that could be minimum. And then again and again, what we did, minimum. Okay, what we did, like we are considering other way around. Let's say it's not good to take land ride first and then water ride. In for this condition, it will consider like for water rides and then land rides again. So it's this line and this line would be matching. Okay, and so the time complexity for this problem is nothing but big of n, right? And n is 1000, that's fine, right? But okay, let's copy this problem as of now and go to the today's problem of the day. See, it's quite same, and so tourist must experience exactly one ride from each category in either order. So there was two category. The problem statement is exactly same. Okay, and the time complexity become tightened, but that solution was also good. Let's check this one first. This is accepted because this solution is giving correct only, right? So the time complexity is nothing but big O of maximum of n or m. Okay, so that's good. Let's try to submit this one only. This should work, but it might be a case. Okay, there is a scenario where okay, I got it. Why this is failing? This is failing because the value for the thing is got increased. In last problem, it was 100 only, I guess. It was 1000 only, right? But like 10 to the power 1 to 3. But this time we have 10 to the power 5. So it would be better if I have like this 10 to the power 1, 2, 3, 4, 5. Yeah, this should work. Or simply, yeah, let's see if it is working or not. Yeah, this is working. Okay, let's try to submit this again. Okay, so this is an implementation problem, and honestly I didn't like solving this problem. This is a bit confusing problem. See, the thing is that what we are doing, like we have some land rights and we have some water rights. What is our goal? Our goal is to uh, our goal is to exactly ride one, at least one land rights and at least one water rights at earliest as possible. Okay, so what could be the scenario? And one more thing is that all the rides has an specific time when that ride is eligible to be uh, eligible for riding. Okay, so basically what could be the scenario? There is only two scenario. Either I will do the land ride first and then water ride, or else I will do the water ride first and then the land ride. Okay, so so how we are solving this? We can do this way. Simply check which ride is minimum for the land ride. Okay, which one is the least, which ride is going to take me the least amount of time for the land ride. Okay, so for that what we have done, we have made min l, so like minimum for the land and minimum for the uh, what it is, water. Okay, water ride. So how I'm calculating this? This is being calculated from the starting of the land ride, when that particular land ride is allowed to be uh, riding ridden on. Okay, so start plus the duration. So that particular, if I consider that particular um, land ride, it will take this much time. Okay, from the very beginning, like from getting into the park, and then this much time minimum admin will take. So we found out the best solution, like best land ride to fun with. Okay, okay, now what we are doing in this for loop, we are doing the same thing for the water ride. Okay, we are finding out the best water ride. Okay, that will take the least amount of what, least amount of time. Along with that, what we are doing, see, we have calculated the least minimum, the amount of time most optimal ride that will take the minimum number of time for the water as well as land. Okay, and then what we are doing, we are just calculating minimum. Okay, we are just calculating the maximum of this, okay, plus this. So the moment, like, what does it signifies, let me explain. Okay, this signifies that my land ride is being done, and my that particular that ith starting that particular ith water ride has the starting time greater than or equal to the complete duration of minimum that particular optimal land ride. Okay, if it is good, if it is maximum, I am considering the maximum value among them. If it is the land ride that is greater plus the duration. Okay, I am doing this, and this combined will what it will make, it will make the actual answer. And this could be the one of the answer for comparing, like we what I am looking for, I am looking for the most I'm in this for loop, in this line, I am just looking for the most optimal, optimal means the water ride that can be configured with the minimum that this min L, so that we will get the minimum result. Okay, RES, this result, this could be the scenario. Or let's say there are some after iterating over all these things, we got some minimum result. Okay, now let's do the other way around. This for loop is just for, let's say we have configured for the minimum of land and minimum of water, and again we also considered some of the almost all of the configuration for minimum of land plus all the particular options with the water, and we stored the most optimal solution in RES. Okay, RES. Now what we are doing, we are doing simply this. So this is what, here what we are doing, we are considering water, most optimal water ride, along with the all the possible almost all the land rides, and we are looking for the land ride that will start um, after the optimal water ride. Okay, this will give me the that value, and along with the land duration we will get some answer. And what we are looking for, we are simply looking for the most optimal, so we are just doing the risk comma this thing, and eventually this is answer. Yeah, this is okay, fine. So that's all for the day, and thank you so much.